Hello and thank you for joining me. So I just wanted to do a quick video here just to outline the differences between using a dual VDOM approach for multi-tenant segmentation versus using a multi-VRF approach. Now with a multi-VRF approach, what we do is we segment various entities within the organization, obviously into a VRF. But then in order to have those share an egress point, we have to create another VRF. Let's call this the WAN or the egress VRF. Now the challenge there is that in order to share routes between these, we have to start, depending on the size and the scale of the network, we then rely on using route maps and prefix lists and route map combinations in order to determine what gets leaked into what VRFs. And then, of course, we've got to overlay those with policies. Now, where we're only speaking about some default routes and one or two routes, then that's manageable. It's fairly simple. The problem is that once that starts to scale, it starts to become unwieldy and it starts to become prone to human error, and then troubleshooting creeps in, and it's manageable for the initial design party, that is the person or persons that originally designed that, documented it and so forth, because that design model is fresh in their head. However, over time, people leave organizations, new people come on board who may not be as skilled, and then when things go wrong, troubleshooting is generally required, is always required rather. And as a result, your mean time to restoration or repair can be anything from minutes, hours, days, or potentially never, depending on the type of complexity. Now, with a dual VDOM approach, we don't get away from having two routing domains, but what we do get away from is the need to have route maps. So, in the dual VDOM approach, I've got here my root VDOM, and I've got two VRFs here, which I'm representing with router symbols because VRF stands for Virtual Routing and Forwarding Instance, right? So here I've called these two corp and CCTV to designate that they are being isolated. All right, it's pretty typical. You have your corporate network isolated away from your OT network. That's standard practice. Then what I want is for these two domains to speak to their corresponding head ends in the data center. So CCTV cameras want to speak to the NVR, and corporate users want to be able to speak to corporate resources sitting up here in the data center. So what we do here is we create an IPsec tunnel, but we create it from the root VDOM here. Now, the VDOMs are interconnected with a high-speed, high-performance, hardware-accelerated link. It's called an inter-VDOM link. And what that means is that this root VDOM has only one view of the world. Okay, that single link going into the WAN VDOM. So the IPsec tunnel, its root, its source, is the inside of this interface. And all I do is I then tell it about the outside of the data center so that it can establish the IPsec tunnel. The WAN VDOM is connected to the internet, the egress direct internet access links, so it's got the routes from the ISPs, so it knows how to get across there, and the route is established. So let's just look at this from a logic perspective. So here I've broken it down, right? So this is in essence what happens. So I've got my WAN VDOM here. I've got my primary inter-VDOM link here. The root VRF here is where the IPsec terminates. So the IPsec tunnel terminates in here. All traffic from the root VDOM egresses via that link, and it says, okay, well, what paths do I have? It looks in its routing table, whatever it's got from the ISP, and then in this case, it will go out towards the data centers, right? Now I've got multiple links here. I'll get to those in a second. Now, once that IPsec tunnel is established, we use VPN v4 BGP extensions to carry the route descriptors for these VRFs, right? In exactly the same way as MPLS would do it, except MPLS would use a label distribution protocol and label paths. So we're using VPN, IP, and IP, which provides the same functionality but within IPsec. But it doesn't matter. Either way, traffic is identified by its route descriptor, its import and export targets, and there the IPsec tunnel knows which VRF to extend the relevant routes that it's receiving along the BGP, or rather via BGP, which is being carried over the IPsec, and the routes appear in their relevant VRFs. Now, that allows for spoke to corporate head-end data center communication, right? So I haven't used any route maps. No route maps are required. The routing tables are simply populated via the BGP. Now, what happens when these VRFs want to speak outside to the outside world? Now, of course, we could inject a default originate always from the hub into these VRFs, all right, so that all the traffic went over to the hub and egress to the internet that way, but that's suboptimal. So generally, if your spoke site has got a direct internet access link, you want to use that. Maybe you're consuming a SASE server from one of the SASE providers, you want to go direct over internet, or you want a combination of both. So what we do here is that using the same methodology, these inter-VDOM links, we simply create 2 more inter-VDOM links. All 3 can happily coexist within the WAN VDOM. The WAN VDOM simply sees them as interfaces. It doesn't care where they're going to, it just sees them as an interface. The other side, within the root VDOM, we put the corresponding sub-interface into the individual VRFs. So these VRFs are still isolated from each other. They cannot communicate with each other. Now, yes, they do share an environment up here, but remember the FortiGate is first and foremost a firewall, and traffic cannot flow between interfaces on a firewall unless you specifically allow that traffic via a policy. So by default, all these interfaces are segmented. So when VRF10 wants to speak to the internet, we have a default route here saying anything you don't know about, anything which is not a longest match coming from corporate, send it up to this interface here. The WAN VDOM then looks at its routing table, and then it says, okay, well, this is SASE. I'm going to use SD-WAN to send it out the IPsec tunnels going to whoever the SASE provider is. Remember, from an SD-WAN perspective, whether these are IPsec tunnels, physical links, or whatever, or GRE links, or whatever you've got there, VXLAN, whatever the case may be, the SD-WAN simply sees them as the interface, and the SD-WAN then applies the relevant logic that you've stated in order to steer that traffic. So if traffic is coming along here, and it's destined for the internet, and the rule here within SD-WAN saying any traffic for the internet must go out to the SASE provider to be scanned, the SD-WAN will send it that way. If the SD-WAN rule says, well, this is internet traffic, but in actual fact, it's a SaaS application we trust, like maybe Office 365 or Salesforce or whatever it is you trust, well, then you will have that policy above the SASE policy, so it gets hit first. And then the SD-WAN will say, okay, well, I'll send it directly to the internet. Okay. The IPsec here is not, in this instance, is being sourced from here. So again, we can use the SD-WAN. Let's say I have 2 internet service providers here, or 2 internet feeds. I've got one IPsec tunnel. They're both being sourced from the root VDOM, but I've got one IPsec tunnel going to data center 1. And I've got another IPsec tunnel going to data center 2, no problem. I simply use the SD-WAN here, and I steer that traffic accordingly by saying any traffic destined for DC1, go out the first interface. Any traffic destined for DC2, send out the second interface. All right, so hopefully that's clear. Now, remember, you will have noticed that I've not used a single route map here in any way, shape, or form. Right, let's see how that looks on the actual device themselves. So here I've got my spoke device, okay? And I'm within the root VDOM, and you can see here within the root VDOM, I have pinned the IPsec tunnels to this interface here. So let's just see what that interface is for clarity. So if I go to the global VDOM is where we create all the inter-VDOM links. I come down here, and you can see that I've got this one. This is my primary link. This is so that the root VDOM can speak to the outside world. And you can give them whatever names are meaningful to yourself, all right? And then when I go in here to each individual interface, I can see which virtual domain each side is in. So that side is in the root virtual domain, and correspondingly, in fact, if I just go to the primary, it'll show me both. All right, so that's in the root, and the other half is in the WAN VDOM. All right? And that's how we do the segmentation. Now, this particular FortiGate I'm using is a virtual machine, so these will be in software on this, but on a physical appliance, these will be hardware accelerated NPU links, or network processing unit links, or ASIC, whatever you prefer to call them. But neither here nor there. If I come back to the root VDOM, that is in essence how I am communicating to the outside world. And if I drop down, I can see that my two tunnels are associated with that. Okay, now those two tunnels, you can see they don't have IP addresses there. It's because they're getting those IP addresses dynamically. If I come to the tunnels and I go into each one, I've put here mode config. Mode config means source the IP address from the hub. All right, so it's like a just refresh that. So if I come here, you can see there's the pool of IP addresses that are being allocated to each spoke as the traffic comes in. And you would have seen there, I've got one dial-up connection coming in. So this is data center 1. If I go across to data center 2, go to my VPN, I've got another dial-up tunnel here, and then this here has got its own. So the DC1 was 10.5.100, this one is 10.6.100, and if I come along here and I do a diag IP address list, okay, there's my 10.6.100, which was that first IP address, and there's my 10.5.100, and you can see there's DC1 and DC2. So those IP addresses are dynamically being distributed to these devices. And you can see that both those tunnels are up. Now, if I look at the static route, all I've said is in order to get to those tunnels, I've got a static route here saying, now, obviously here I know that my DC1 and DC2 are within that subnet range, but it's irrelevant. You would have an equivalent here for whatever your destination, or you could have a wildcard. You can have multiple wildcards or 000, because these are all in different VRFs, so they don't care that there's multiples. If I had any IP address or a default route here pointing there, it wouldn't affect these above. So all it knows is that in order to instantiate either of those tunnels, it needs to cross this boundary to get into the WAN VDOM. Okay, and at the WAN VDOM, I've said, well, the next hop in order to get to those is via the next. Now I've got a router between all these FortiGates, and this is the next hop or the default gateway of that router. Okay, if I look in the WAN VDOM, you can see I've got no VPN tunnels here whatsoever. I've only got a simple policy saying allow everything out to these traffic out to the internet, and this is from the traffic coming from each one of the VRFs, which I'll get to in a moment. But this is basically what is coming from the LAN WAN, so that inter-VDOM link, going out of port 2, which is going to the router, and it is establishing that those IPsec tunnels over this link. Let's take port 3 out of there. Doesn't need to be in there. It's not being used. Okay, so that makes things a little bit clear. And this is the internet traffic coming from each one of those VRFs. So if I come back here and I look at my interfaces, if I come here, so I've created, because I don't have any hosts created, I've created a loopback in each one of these VRFs. So I've got a CCTV loopback. and that's in VRF11. And I have this one in VRF10. And then correspondingly, I have got these interfaces. Remember those interfaces that I dedicated to the VRFs. So let's just go back here. So here's VRF10. Remember, I've got a dedicated link here so that VRF10 can get out to the WAN VDOM. So this would be this one. And we can see that that's in VRF10. And conversely, if I hover over this, that one's in VRF11. We can see it clearly if I do a get router info routing table all. Okay, here are my tables. My VRF10 table has got its connected routes. This is its next hop going out to the WAN VDOM. These are the BGP routes that it's learning from the two data centers. Okay, you can see data center 1 and data center 2 there. And here is its connected loopback address, and the same for VRF11, right? If I come to DC1 here, DC1 has also got dual VDOMs. In the root VDOM here, I have got loopback addresses, and I am sharing those with the WAN VDOM via OSPF. Okay, so that's the root VDOM, and it's sending these loopbacks over to the WAN VDOM. And then the WAN VDOM is taking those OSPF routes and it's redistributing them via BGP. Okay. And conversely, the BGP the BGP is redistributing the OSPF, and the OSPF is redistributing the BGP. So from the data center side, if I come to the root and I do a get router info routing table all, these were those loopbacks on the spokes. And you can see that they're being learned via OSPF as an external type 2. Why? Because they have been redistributed from BGP into OSPF. Conversely, if I come here, I can see that these have been redistributed from the OSPF on the data center side. And you can see the V means it's BGP VPN v4. And that is because, if I do a show routed BGP, this is where we're doing the VRF imports and exports. But if I do a show router route map, there's no route maps there. Show router prefix list, there's no prefix list there. All right, it's very simple. I'm simply using VPN v4. So if, for example, I want to do execute ping-options source 20.1.1.1, so that's coming from VRF10 on the spoke, and let's say I want to talk to something in VRF10 here, so 11.1.1.1, execute ping 11.1.1.1. Okay, I can ping quite happily there. But if I change that source to 21, I wouldn't be able to ping it because 21 is in VRF11. So I've got that segmentation all the way across the network. But let's say I wanted to ping 12.1.1, which is in VRF11. I can ping that. Okay, so all that segmentation is happening from spoke all the way through to the data center, very simply using VPN v4. Sorry, let me just go back to my routing table here. All right, so I've got all those routes. All those routes have been learned. They've all been shared. There's no route maps being involved, no prefix lists. Very simple. Now, I've also got the static routes pointing out to the WAN VDOM for each one of these. So if I want to ping the outside world, let me just execute ping-options view. And this just shows me that this is coming from VRF11. Execute ping 8.8.8.8. That can get out to 8.8.8.8. And if I change my source to 20.1.1.1, likewise I can ping. And that's because now Because there's no longest match going to a specific longest match which exists within the IPsec tunnels on the data center, well then each of these VRFs has to look at its gateway of last resort, which now becomes this, and that will then steer it to the WAN VDOM, and it'll then get sent out of the respective link here. And as I said, I'm not currently using SD-WAN in this particular build, but I could quite easily do so, and I'd be able to steer the traffic as appropriate depending on the links. So hopefully that was clear. If not, then by all means feel free to reach out to me, and I will add more color to this video. Thank you very much.